Welcome to part 7 of coding Slither.io in Python using the Pygame library. And before we move on to adding body segments to our snake, because right now it's just one head, no matter how many orbs we get, the snake isn't growing. But before we go on to growing the snake, I want to talk about class inheritance, which is a pretty important programming concept. So I have Paint here to explain this concept. Imagine that we are making a zombie survival game. So it's going to have three kinds of people. There's going to be players, zombies, and citizens. So other people that are getting hunted down. So imagine as I type this, I would code a player class, which would have a texture, it would have health, the player would have, what else would he have? He would have a position. And then, since it's a player, maybe the player has a score and an inventory, like that. And then I'm going to move on to the other classes. The zombie class is going to have texture as well, health, position, but it won't really need score or inventory. The zombie will have a target, which will just be the position of, say, the nearest human. And then finally, I'll have my citizen class here, like that. And the citizen will also have texture, health, position, like that. So as I'm coding this game, you can see there's a whole lot of copied data. Data we're doing twice. We have texture, texture, and texture. We have health, health, and health. But I can't really get around that because all three of these classes need those things. All three of them have position. So really, if we look at the unique stuff, the only unique attributes seem to be these that I'm underlining here: score, inventory, and target. And this is a bad way to be programming because you're doing a whole lot of extra work. All this stuff here, all this, I'm not really circling this well, all this we're repeating, and we don't want to repeat it. So a better game structure would be to use something called inheritance, where I'm going to make a parent class called human, and human is going to have texture, health, position, and just those three things. Now, when I make these three subclasses, I can make them with just the unique variables, but they are going to inherit from human. So let me finish typing these out, and then I'll explain what I mean by inheritance. So zombie has target, and then citizen has no unique properties. So I'm just going to type citizen like that, no unique properties. By inheritance, I mean these common properties, these classes are going to inherit from the parent class, human. So the human is referred to as the parent class, and player, zombie, citizen are all child classes. And they're all taking these common properties from human. And so what this does to your code is it makes it a lot more organized. You're not reusing extra code like you are down here. The only thing it costs is using an extra class, but in the long run, this is going to be a lot more useful. Now, why did I bother explaining all that? I explained all that because in our Slither.io game, if I take a look at our orb class, we have a draw function that's exactly identical to the player's draw function. The orb has a rect and a texture. The player has rect, texture, plus unique stuff here. And then they both have update functions. There's a lot of code that we're rewriting that we really ought not rewrite, which is why I'm going to use this concept of inheritance in order to rewrite this code, make it more organized. So what we're going to do is add a new class called object. And in the object class, in this class, this is just going to contain all the data we need to draw something to the screen. So the object is going to have all this in all the commonalities between orb and player. So object will have rect and texture, and it's going to have this entire draw function. And that's something I didn't explain. When you use inheritance, you don't just inherit variables, you can also inherit entire functions. But we'll get to see that in a second. So I'm going to write class object, and I'm going to create the constructor almost just like the other ones. So it's going to have an x, a y, a width, and a height, plus a file path for the texture that we want. And then I'm going to write the exact same code as before. I think I can go ahead and copy it, actually. I'm going to copy this code. Oh, but be careful when you do copy, because sometimes you'll copy stuff that's slightly different. For this, I need width and height, not radius and radius. That was unique to orb. Alrighty, so now this constructor is going to contain all the common variables that we have between orb and player. And now I'm also going to take the entire draw function, because frankly we don't need to write the exact same function in two different classes. That's going to be a waste. So I'm going to copy the one from orb, and I'm going to paste it into object here. And right now, we have our basic object class. I'm going to import Pygame. I'm not sure entirely if I have to here, but I'm pretty sure I do. Import Pygame. And now I can go over to orb, and I'm going to delete this draw function. I'm going to go to player, delete this draw function. Now, in player, I'm going to delete all this information here that we repeated, since we have all of it inside of object now. And in orb, I'm going to delete all of this here, and I'm going to put a pass statement for now. So you may be wondering, oh, and these parentheses should not be here. You may be wondering, how do we actually tell one class to inherit from another? How do we tell the human or the player to inherit from human, the zombie to inherit from human? How do we make that parent-child distinction? In Python, that is pretty easy to do. First, I just need to import the parent from object, import object. And then for the orb, when I write the class declaration here, I'm going to add two parentheses, which were there earlier. And now inside of here, I'm going to put object. And this specifies that you are using object as a parent class. So now orb is effectively borrowing these properties here. But this constructor, I do need to do something about this. I don't want it to just be empty. In order, the next step to actually finish inheriting everything from object, because right now these variables, even though I am now inheriting by putting object here, I still need to actually take these variables. And the way I'm going to do that is I'm going to call the parent's constructor. So this is the child's constructor, this is orb's constructor, but I'm going to call the parent constructor by typing super with parentheses, dot, underscore, underscore, init, underscore, underscore, because that's what the constructor is. And inside of here, I'm going to put the same parameters that object needs, which is x, y, width, height, file path. And then I'll explain why I'm doing all this. So x, y, and then since we're using an orb and they were all circles, I just had radius, so I'm going to put radius twice, and then file path. Now this line of code is necessary, and the reason I'm doing it is because this will effectively initialize all these variables. I cannot use any of these variables, I cannot put them inside of orb until I call this function. Super refers to the parent. So the parent is object, so it's going to go over to my object file. And using the parameters we just passed in, it's going to execute this exact code here. So it's the same, this is the same as if I typed in those variables myself, self.rect, and then all that other stuff. But we're using inheritance, which is going to shorten up our code. So you can see how this class is much cleaner than it was. We no longer have that repeated rendering data, since all that data here is just for rendering. We're repeating it all. and then we no longer have the repeated draw function. Now I'm just going to do the exact same thing to player. I need to import the class from object import object. Then I need to specify the parent. The player is the child of object. And then I'm going to make a slight change because object's constructor requires a file path, but players does not. That's because we had always been hard coding player to be bodyred.png. There was no random textures like the orb. It was just always this one. But we're going to go ahead and change that add file path just because we're going to need to when we call this constructor. So I already deleted that old information. Now I can just type super, refers to the parent, dot, and then we're going to call the parent's constructor with x, y, width, height, file path. That's why I needed to add this. And now the player is also effectively inheriting from our object class. And so both our player class and our orb classes are much nicer now. Our code is being reused when we do it this way. And I know it's not super necessary to do this, but the next class we write when we do body segments is also going to inherit from object. So we didn't want to rewrite this code 3 times for 3 different classes. So now let's make this inheritance take place. So player, we made a change, added file path. So I need to go to main.game.py and find my player. I create the player right here, and all his attributes are here. I could just put bodyred.png here, but instead I'm going to define it as a constant here. Player texture is equal to bodyred.png, like so. And then this, I'm going to copy this value, and I'm going to pass this into the player's newly modified constructor, like that. And now, I believe unless I made a mistake, and I didn't. So right now, the game is exactly the same as it was before. It doesn't run any differently. The only thing we did was make the code better. And really, this isn't going to help us very much now, just because we only had 2 classes to change. But imagine if our game had a ton of classes that all just repeated data like that. Imagine we had 6 classes that all repeated, they all needed texture, health, and position. I'd have to write that code 6 times, but inheritance means we only have to do it once. So this gets more and more useful the more code we add to our game. So now with our inheritance lesson out of the way, let's add the segment. So I remember explaining in one of the earlier videos, I'm going to make some room now that we're done here. The way I wanted to do slither.io, I'm not sure exactly how the game itself works, but the way I was doing it was I was going to have the head, and then every single time we accumulate enough points, we're just going to add another segment, and we're going to put it about halfway, like so. And that's not exactly the nicest. Maybe if you want to be more precise, I can make it, 3/4 of the way, like that. But this is generally all we're going to do. We're going to add an entirely new circle. I don't know what the game does, if it stretches it out or something like that. But this is how we're going to make the snake mechanic. So we have the head. The player is the head. It responds to movement. But we need a body segment class that will respond to movement by following the head. So that's what we're going to work on next. I'm going to create a new file in slither.io in the project. Don't know why I need to specify that. And I'm going to call it segment.py. And you can call it something different. This is how I'm going to refer to it. Segment.py. And now this is where we're going to use our object class. Right now, segment still needs a rect, an image. Well, this isn't a private variable, if you recall. This is just a variable that we use to resize the picture later. But now I'm rambling. The segment needs all this extra data, so we're going to also inherit from object. So import pygame. One of these days I'm going to test and see if I need to put that there. From object, import object. class segment, the parent is object. The constructor is going to look almost exactly the same as everything else we've been doing. We needed a starting x, a starting y, a starting width and height for whenever we create our segments. And I'm also going to pass in file path even if the texture never changes. We did that with player, I'll do it here. I'm going to call super, which is the parent, and call the parent's constructor so that we can actually take advantage and get access to those variables. All right, so that's the beginning of the segment class. And right now we would be able to draw segments to the screen. Let me also give it an update function because it's going to need that. The way the updating is going to work is, oh, and this is really messy. The way the updating is going to work. Oh, I didn't know you can do that in Paint. That's nice, but I don't want to do it there. The way updating is going to work is we're going to have the player head, and when the player moves, the segment is going to follow it. But if there's 3 segments, this one will follow this one. And all of that we're going to code today. But for now, I'm going to define update self, and then I'm just going to put a pass statement. Oh, and by the way, you might be wondering, why didn't we put the update function inside of object? And in fact, we could do that. The way I see it, all their update functions are going to be a lot different. The orb only checks to see if it touches the player. The player only follows the mouse, and the segments are just going to follow whatever segment is next and or head. So there's not a lot of similarities between them. In object, I can go ahead and create an update function, define update, and then make a pass statement. So this is a way of just telling our code. Well, actually, I don't really need to go there. So if we ever want to put something in here, we can. We'll just leave it for now. This down arrow tells us that this function is getting overwritten, which is something I also didn't explain about inheritance. If you have one class, if I have my human class and he has an update function like that, and my child player class also has an update function, if I ever create a player and I say player.update, it's actually going to call the player's function here. It's going to call this one because even if these two functions are completely different, this lower one overrides the upper one. But sometimes it's useful to have the upper one as a placeholder. So that's enough about that. We've made enough changes to object. Now let's add some segments to the player. So as another unique variable for the player, I'm going to have self.segments, and I'm going to define that as an empty list. Next, I'm going to import the segment class because the player needs to be able to create new segments. And so that's the start. We're not actually going to add any segments yet. What I want to do is just control when we add segments. This is going to be really simple. All I want is to add a new segment whenever the score increases by 20. So what's going to happen is the score will be 0, then we'll increase it to 20, and then we're going to add a new segment. But to keep track of this, I need a previous score variable. Because the way we're going to do this is every single time the orb touches the player, we're going to add to score. And score is going to get bigger and bigger. I think we increment by 5 every time. And then finally, when the score is 20, we're going to be able to say or see that previous score is exactly 20 less than score. So that's when our game will bump previous score up to 20. And now these are the same. And we're not going to add a new segment until we add to the score. The player keeps collecting more orbs. And then we get 20 above this one. Then previous score will get bumped up. And then we add a new segment. So that's how that's going to work. These stay initialized to 0. So I'm going to go to the orb, and we're going to do just that. So we're already incrementing the score. Oh, I think I made this change without actually saying. So we're just saying player.score plus equals 5 earlier in a previous tutorial. I changed it to a constant, and this is all good. I'm going to go to the player class, and what I'm going to do is I'm going to do that check. If the difference between the score and the previous score is 20, so if self.score minus self.previous score is equal to 20, then we want to bump previous score up to wherever score is. And then we're going to add a new segment. But just to make sure this is working, I'm just going to add a print statement like that, just to make sure our score system is working correctly. I'm going to run, and I'm going to run into exactly 4. 1, 2, 3, 4. And right over here, I get add segment. I'm going to do it again. 1, 2, 3, 4. And we get another add segment. Alright, now we should actually render some segments onto the screen rather than actually getting add segment. So what I'm going to do for now is make this spawn a real body segment. It's not going to follow the player yet, it will just be there on the screen. And here's how we're going to do that. We need to be very careful as to where we actually choose to spawn in the new segment. So imagine this is a player head. This is how we need, in Slither.io, as you get longer in the direction opposite of where you're going. So if the player is moving to the right, anything added to him gets added to the left. And here's how we're going to accomplish that. When we do our player movement, we're already calculating the position of the mouse, and then we're getting the direction vector to that mouse position like this so that we have a place for the player to go. What we're going to do is we're going to take that same vector, which we calculated in a previous tutorial, using the formula, and I'll just, as a review, using the formula target position minus player position, or minus your position. The direction vector between two objects is the target minus the starting. We're going to take that same vector that we got in the last tutorial, and we're going to flip it in the opposite direction because that's where we want to spawn the new segment. And then since it's already resized to 1, I mean over here we multiplied it by speed, but we're just going to take the shorter one. Okay, ignore that. When we flip it around, we're going to then resize it to where it's exactly the length of the player. So if the player is, let me use a different color. If the player, oh, and I still have the line selected. So if I get a new line, if the player is exactly 1 radius, if this is the player's radius, that's how long we're going to make this vector here, just times 2. So basically the effect is, I kind of said that poorly, but the effect is that when we create a new segment, it's going to be exactly halfway. We're going to take the direction vector from the mouse, we're going to flip it around, we're going to multiply it by the size of the player like this. And that should give us a segment that's kind of halfway between them. Now, as soon as the player moves somewhere else, the segment's not going to follow. That's okay. That's what we want for now. So, right here, dist_vec, that's that vector that I was saying here from a previous tutorial. This is the vector that takes you from the player to the mouse because it takes the mouse's world position minus the player's position. So this is what we're going to do. The first thing we're going to do is flip it around. And the way you flip a vector around is you multiply its x and its y times -1. So that's multiplying the x. Now I'm going to multiply the y by -1. And the next thing I'm going to do, since again this, when we normalize the vector, which means you shrink it down to a length of 1, we normalized it right here. And then when we added it to the player's position, we didn't actually change its length, we just multiplied it by speed here. But now we're going to actually take this vector and we're going to multiply it and resize it to be the length of the player. So I'm going to multiply it by self.rect.width. And I'm going to do, just to be consistent, self.rect.height. Even though we're dealing with an orb and there's no difference between these, we're dealing with a circle. I could just do width for both of them. I could do height, but this makes it a little bit more clear. So we took the vector, we flipped it around, and then we stretched it out to be the length of the player. So now the next thing we need to do is actually get in that new segment. So we need to calculate its position. And its position is just going to be, I think it's actually just going to be this here. In fact, I could have done it that way. So the starting x for the new segment is just going to be distvec 0. And in fact, I'm going to go ahead and put all this in one line here since I don't need to split it up like this. So here's where I'm going to multiply by -1 and then multiply by the width of the player. So I'm going to copy that. I bumped the mic. I hope that's not getting heard. Distvec 1 times -1 times self.rect.h. So I can actually get rid of this. Since that was an extra step, I can do it all in one step. So the starting x position and the starting y position is going to be the flipped distance vector multiplied by the length of the player. And just to visualize this again, this is the distance vector. We take it and, oh, I want the line. We take it and we flip it all the way around. Now it's at the length of 1 right now. Then we multiply it to be the length of the player. And here, this position here is where we're going to add that brand new segment like that. So just to visualize what we've done, we have a starting x, starting y. Now we can go ahead and create that new segment. New segment is equal to segment, and I'm going to put in the starting x, the starting y. Now the next two parameters are the dimensions of the segment, and we want it to be the exact same as the player. So I'm going to put self.rect.width, self.rect.height. And then the file path, I'm going to make it the same as the player. I can't pass in the file path from here since that's out of scope. This isn't the constructor and it would be undefined here. I'm just going to hard code it to the same thing we've been using for the player. Body red.png. And now we need to add it to our list of segments. Self.segments.append new segment like that. And this would create a new segment whenever our score is added. We no longer need this print statement here. But we still do need to draw them. And oh, and I left that code from when I was doing it last. So I'm gonna delete that. So earlier we took the draw function out of player and we put it inside of object, but I'm actually going to take it back. And the reason why is the player's draw function is going to also have to draw all the segments. So I know that seems kind of like a waste of time, but I didn't see that coming. So after we draw the player, we're going to draw all the segments that also are a part of the player. So for segment in self.segments, and then I'm going to copy most of this. Window.blit, that's the Pygame command that'll draw a texture. We need the segments texture, segment.texture, and then we translate it using the segments position. So this would be segment.rect.x, and then segment.rect.y. And so that should draw the new segment whenever we have created it. I'm going to go ahead and run. And we got no compiler errors. Okay, that's wrong. So it added a new segment, but it did not put it at the right position. So I'm going to see if I can quickly see what I did wrong here. So this is where we add it. The starting x is just the distance vector flipped around times the width here. New segment is equal to segment. So I'm going to go ahead and pause, figure out what this is. Alright, I found what I did wrong. So I forgot this is literally just a direction vector right now. I have to add back the player's position plus self.rect.x and then plus self.rect.y like that, because what we're doing here is it's the same as a vector tutorial. This blue vector, it means nothing until we add it to the player's position, and otherwise it just has nothing to reference. That wasn't a good explanation, but we need to add the player's x and add the player's y to this. This is just like a little offset. We need to give it a starting place to work from. But aside from my bad explanations, if I run this, I now get what I want. The segments appear right where they should behind the player. And again, they disappear immediately because they have no way of moving themselves. So let's add how they're going to move themselves. So in segment, we need to update the segment. And I mentioned earlier that the segments follow either the segment in front of them or the player. So either way, we're going to need a target position for the segment to follow. We don't know what this is yet. It's going to be either the player or the next segment in line. But right now in the update function, we're going to put the vector calculation that's going to be really similar to what we did for the mouse. So it's going to be almost identical to all this stuff here. So the first thing we need is to get the difference vector, or the difference vector, because if I have one segment here, the player here, it needs to calculate what the vector is between itself and the player. And that's using the formula target minus start. So for the segment, it's just going to be the player position minus the segment position. Or in this case, it's just the target position. So I'm going to call it direction. And our direction vector is just going to be target position 0 minus self.rect.x, target position 1 minus self.rect.y, like that. And then the next step, and I don't need this pass statement anymore, the next step is to resize this vector so that it's not instantly there. It doesn't teleport our segment to the player. We need to resize this vector so that we can control its speed. And this is getting kind of messy. I'll delete it and I'll add more to it as we need to later. And I did that again. I realized the second color here is the erase color. Alright, so now let me resize that vector by calculating the length. If you need a review of this, I would just watch the last video. The length of the vector is just direction x squared plus the y squared raised to the half power, or the square root. And then I'm going to take direction 0, or the direction in the x, and divide it by length. I'm going to take the direction in the y, divide that by length. This is almost exactly what we did for the mouse. There we go. And now for a direction vector to be meaningful, you have to add it back to the position. So all that code calculates our direction vector. Now we need to add it to the position. So self.rect.x plus equals direction 0. And we need a speed. I just realized our segment doesn't have a speed, so let's add one. Self.speed is equal to speed. And we're going to add that in the constructor as well, speed. And real quick, before I forget, I'm just going to go ahead and add that to, where do we create the segment? We create it right here. x, y, width, height, texture, speed is going to be the same as the player. Self dot speed. All right, now we can go back here. Direction times self dot speed, self dot rect dot y plus equals the direction in the y times self dot speed, like that. Now, this will not, I'm not going to run the code yet because we actually need to call this update function. So I'm going to go back to player, which is underlined red for some reason. I don't like that. What is it complaining about here? End of statement expected. Oh, I need a comma here. Body red, and then self.speed. There. So we need to actually update each segment. So inside the player's update, and I'm going to create a for loop that will update each of the segments. And I have no problem doing this in the player because this is all basically a part of the player's body, so it's all fine. For I in range length of self.segments, like that. Now, this is where it's going to get a little tricky. What we want is now that I have a clean slate, if this is the player, and then this is the segment here, and then this is another segment, I want this segment to follow the player, and I want this segment to follow this segment. So the target position is going to be different. Here's how we're going to give it the target position. If I is equal to 0, so if this is the very first segment in the list, that means it should follow the player. So we're going to say self.segments.update, and we're going to pass in the player's position. Self.rect.x, self.rect.y. But if we're anywhere further along in the list, so if we're not this one, if we're anything past the first segment, we need to just follow the next segment or the previous segment. So self dot, oh, and I forgot a bracket, so this should be segments I, and then here self dot segments I dot update, but instead of passing in the player's position, we're going to put in the previous segment's position, which is self dot segment I minus 1. That's why we're using an index for loop. We need this I counter. Dot rect dot x self dot segments, I minus 1 dot rect dot y. And that will pass in the player's position as a target for the very first guy in line, but then everybody else is just going to follow the one that came before them, like this. And I really hope I didn't make any mistakes. I might have. We'll see. And we have a segment following the player. Look at that. Let me add another one. And this is, I expected this. We're going to talk about why that happened in a second. But first, let me see if I can get, there's one. And there's two. Player has no attribute segments. Oh, it should be segments. I minus 1. That's not the bug I was thinking of. So I want to see how many we can add. There's 1. There's 2. And notice how they're all rapidly getting close to the player. And I tested this previously. Eventually, as I turn, they all get closer. And eventually, it will crash. Doesn't seem to be crashing yet. But let's talk about why that's happening. So these segments have no control of their, they have a speed variable, and you would think, well, wait a minute, we passed in the same speed as the player, so shouldn't that mean that they'll always be the same distance apart? Well, what I'm guessing is happening, and I don't know this for sure, but I'm guessing that as the player takes a sharp turn, they're not going to follow the player's track this way. Man, this is getting really sloppy. But these segments are just going to follow the straight line. So they're going to cover the same distance the player did, but they're going to do it shorter because the shortest distance between 2 points is a straight line. So eventually these segments are all going to catch up to the player until we get what we saw on the screen a second ago. They were all squished together. That's why we're going to make some changes to segment. We're going to prevent the segment from moving if it gets too close. So if this guy gets too close to the next segment, we're going to tell it to slow down, and it's not going to be able to move forward. So here's how we're going to do that. In the segment.py, I'm going to add a little bit of extra code. So here we calculate the length of that segment. Well, if that length is any less than the width of the segment, then it's moving too close. So I'm going to add here, if the length is less than self.rect.width, then we're just going to return. And what that will do is exit this function prematurely, which skips over all the movement code we have down here. And I need a colon, that's why it's complaining. And this should help the problem quite a bit. So now it's getting forced at a constant distance away. And look at that. Now the chain is working correctly. But I don't quite like the way this works. We got two issues. Let me see if I can find more orbs. I'm going to go to main game, and the number of orbs is 20. I'm going to make it 200 because I want you to see this. I'm going to run it. Okay, so that's crazy, but I'm going to add, and notice how as I add more orbs, oh, now they're not even getting added in the correct position. I have no clue what's going on. So let me fix the first bug. The first bug is that it's a little bit too far away. So maybe instead of self.rect.width, it should be self.rect.width divided by 2. Because what I said at the beginning of the video is I want this guy to be kind of halfway overlapping with the next one. Or let me draw a new circle so you can really see that. I want the next segment to overlap about halfway. So instead of stopping him if he is one full distance away or less, we should stop him halfway. So divided by 2. Let's see how that looks. And okay, so that looks better, actually. That looks much better. And for some reason, I'm not getting any other orbs that are spawning right now. Let me figure out why that... Oh, I know why it is. Let's take a look at our code. So we're not getting any extra orbs. Well, we are getting them, but they're all going to the player. Remember, the way this should work is they go to the back of the line, but whenever we create a new orb, it's just getting added right here, where the old one was. We need, and I keep saying orb, I mean segment. This needs to go in the back of the line. And right now they're all going to the front of the line, which means they're covering each other, which means it doesn't look like the player's getting any longer. So we're going to fix that. In the player's update function, we need to see if this is the first orb the first segment, excuse me, I keep doing that, the first segment that we're adding. If this is the very first segment that we're adding, then we want it to spawn at the player, which is why we're adding the player's position. But if it's not the first segment, we want it to spawn at the previous segment's position, plus that little offset we calculated. So I'm going to add that logic here. We still need the distance vector multiplied by -1 and all that. But I'm going to add an if statement. If the amount of other segments, self.segments, is equal to 0, so if this is the very first one, then what I want is and this should be declared outside. I'm going to do it like this. I'm going to take this out, I'm going to put it outside the if, and I'm going to take out this position part. So this is just the offset. This is the space in between. but we are not, the position's gone, so this won't work by itself. If this is the very first segment, then we're going to say that start x plus equals the player position, like that. Start y plus equals the player position, like that. And I know that was really confusing what I just said, most likely, so let me try to clear that up again. So I'm going to clear all this. And just to make sure I'm being clear, since that was a really bad explanation, we're spawning the player in like this. The player is just a circle, and then we create a new segment based off of where the mouse is. We take that, we flip it around, and we multiply it so that it's exactly one player width away. And then we add this direction vector. This is just a direction vector that you can add to anything, and it would make that object move this way. Or actually this way. We're going to take that vector and add it to the player's position so that the final position is here. And this is where we add that new segment. But I took away the adding the player position, which means that the vector is just kind of by itself. It's just floating around. So let me go back to the code. If this is the very first segment in the list, we're going to add the player's position, and then we're going to spawn the new segment, which we're doing at the end anyways. But otherwise, if there are other segments in the list, then I'm going to say the start x plus equals the previous segment's x. And by the way, in Python, you can get the very last element of a list by going -1. So for us, this is the previous segment dot rect dot x start. Oh, what did I do there? I don't want that. Start y plus equals self dot segments, the back one dot rect dot y. And then we're going to spawn in the new segment. So now we should get around that problem where the segments aren't all going to be occupying the same spot right here and just all drawing over each other. They should now form a line, which it did a second ago, and I don't know why it did. And it's not quite working, so I'm going to figure out what the issue is, and then I will show that to you. Alright, I solved the issue. It was a really weird issue, and I noticed it only happened when I cranked up the number of orbs from 20 to 200. What was happening was the player was touching so many at once that the score accidentally jumped above, or this is what I think happened, the score jumped above 20. So even though the difference between the score and the previous score was greater than 20, since it wasn't exactly 20, we stopped adding on new orbs. So what I should do to account for that is say if the difference between the score and the previous score ever gets above 20 or equal to 20. So that will keep that issue from happening again, where the player touches, say, 3 orbs at once and he goes above 20. Because now if I run this, I indeed get the right result, and you do get segments getting added to each other. And this is really good. Now notice at the end of the line, as I add a new segment, it just kind of bounces on and it looks really bad. But once the segment's been there for a bit, then it falls into its correct place. I'm going to play it again so you can see it. So it starts out really wide, but then as I start making turns and it gets closer, but then the other ones are not close, and then I turn, it gets closer. And it looks pretty bad. The reason why is we're telling the segment, don't get any closer than half of the width of the player. But when we spawn the segment, we're telling it to spawn the whole distance away. So I should divide both these values by 2 when we spawn in the segment here. And that will keep that from happening. So now, when we add new segments, it looks much better. And this is the end of this tutorial. I have no clue how long it is, and I apologize for some of my bad explanations. But if you followed along to this point, you now should have what I think is a really nice looking snake for Slither.io. And now that we have this, we can in the future begin working on AI. So kudos to you for watching this long, and I'll see you in the next one.